Features of data representations. You need to be able to comment on the shapes of data representations. The most common would be symmetry versus skewness. The diagram below exhibits symmetry, and that should be fairly obvious, as does this one. They're both symmetric, but they're not the same. With the first one, we certainly have a peak right in the middle, whereas with the second one, we have two peaks which are more towards the outside of the data. With real data, it does not have to be perfectly symmetric to be called symmetric, but in any sort of question that you get, it will be very, very close to symmetric. Skewed data either has the bulk of the data at the left-hand end becoming sparser as we move to the right. This is known as positive skew. So basically the shape is like this. Now you know that this is the positive x-axis. It's called positive skew because it looks like we're stretching the data towards the positive numbers. It can also have the bulk of the data at the right-hand end becoming sparser as we move to the left, and that's negative skew, and for the same reason. What we've done is we've stretched the data in the direction of the negative numbers. So positive skew looks like this. It's sometimes referred to as skew to the right. So it's pulled out to the right. And negative skew looks like this, sometimes called skew to the left, and you can see the data is stretched along there. Modality. We know that the mode is the most commonly occurring piece of data. The modal class would be the class with the highest frequency. We can tell the modality of data by looking at the representations. This one is called unimodal because it just has the one mode. This one's bimodal because it has two modes. Gaps, clusters, and outliers. These should be self-explanatory. The first graph here exhibits gaps and clusters. We've got gaps here where there's no data, but we've got these little clusters of data. Sort of here, here, and here. Whereas this graph has a potential outlier. Most of the data we can see is over here, as it was with this one. And then we've just got a single value that's off there.